Так, no sound. Yeah, it's because I wasn't speaking yet. I'm just preparing the stream. So and now first of all I'm going to show you KiCad a little bit, just for you to show what I mean about the parts that could be shorted. So let me switch to the backboard and switch the screen to and I also need to okay, should be visible. So, oh, okay. Let me see. Yep, here's the chat. Okay, now I see the chat, and I can just alt tab to it if necessary. But we actually need another board. We actually need the Delta revision, so it's much simpler. Okay, not much, but a little bit simpler. So the MCP interrupt trace is here, and the idea is that you split the trace into two pieces here, and and here. So here's a cut, and here's the MCP here's the MCP interrupt part, and here's the transistor, and here's the ID clock part, ID is SC. And even though on this revision it's not called IDSC, on the next revision it is. And the point is that you split the trace here, but you also need to make sure that these two pins, basically these two pins, which are connected to MCP interrupt, and this pin, this trace, which is connected to this clock line, and also this GPIO pin, none of these traces short to, for example, 3.3 volts. And okay, we don't actually have a VBAT here, but it's here, this trace, and also that they do not short together. So what I'm going to do, IDSC, so it's actually here, this one, but on Delta revision it's a single trace on the PCB files. But if we open Delta C, we should be able to yeah, I think this one, yeah. So as you can see, here's the MCP trace. Even though it's not marked as such, it's only because it's going through this 1.8K resistor. And here it's through a transistor, it turns into ATSHA. So on delta B revision we have a proper transistor footprint, but on delta revision we don't have, and so that single trace is marked as MCP int. But basically after the transistor, I just call it ATSHA. The point being that these two things shouldn't short onto each other, like these two pads, and also these two pads of the 1.8K resistor shouldn't short onto each other, and this interrupt trace also shouldn't short onto the ATSHA. And I'm going to go ahead and check it with the multimeter. I'm just going to have to focus it. The color is kind of weird. I might have to adjust the white balance. Okay. And the camera holder as well. Sorry for all the squeaky sounds. The camera holder, which is not a holder, it's a lamp. The lamp keeps no short between ATSHA and MCP int on my board. That's awesome. That means that you have made the cut as you should have. I actually had to check, and it turned out that on some of my boards I forgot to make the cut before soldering. So there was that. Okay. Oh, what the hell is going on with the white balance? Okay, this seems more natural. Yeah, okay, let's maybe try this, maybe a little bit lighter. Yeah, I think like that. And now focus the camera. At least try to. Yeah, something like that. Focus. Perfect. If not fully perfect, then almost perfect. So what I'm going to do is I'm going to take a multimeter, and I'm going to turn it on into short detection mode, short circuit detection, and I'm going to put so MCP interrupt pins are 5 and 6 from this corner, so I should have a connection between those two pins, and this one and here, and I do. Here I shouldn't, here I also shouldn't, and I don't. I do have it here. I don't have it here. Okay, beautiful. And the clock output is also accessible here on this resistor. and also on the corresponding pin that's connected to the pull-up resistor. So now I can see if there is connection here. That's important. Okay, here there shouldn't be, and here there also shouldn't be, as well as here. But it should be a connection to here, and there is. That's pretty much it. Oh, and also I can basically just connect to ground somewhere. I think, yeah, the ground is here on this pad, and I can just see if anything is shorted to ground. This pin should be. Oh yeah, okay. So I have a ground connection now. And nothing seems to be shorted to ground except things that should be. So maybe this pin. This pin should be shorted to ground. Oh no, what's happening? That's weird. Okay, that's not exactly what we need to be checking, but it is. I can't see the pin. You mean on the 40 pin header, the one with the resistor? Basically, it's the ATSHA pin is connected right to this resistor. The resistor is connected right to this pin. So here you go, and it should be connected to the transistor's output, but not the input, and not the MCP interrupt, and not the 3.3 volts signal. Okay, so that's how I connected the adding a tag on Twitch. Finished. Okay, so for a start, with soldering, I can a short between what and what. That's an important question. Just let me know and I can try and help you a little bit. Between the current GPIO pin, you mean the ATSHA? Here it has to be a short, and here it cannot be. So you have a short between that GPIO and this point, right? And 3 volt 3. So let's see. Do you have a soldering? Do you have a hot air station? Basically, what I suggest you do at the top of the 10 resistor, at the top. Do you mean? You don't have a hot air station. So MCP interrupt is shorted to 3.3. Do I get it? Do I understand it correctly? Probably going to type it in chat. Ah, so do I understand it correctly that there's a short between MCP int? Okay, yeah, wait. Uh, sure thing, I can wait. Ah, so 3v3 to MCP int. Okay, yeah. So just to clarify, this part from the transistor to the clock, to the EEPROM clock on this pin, and to GPIO header here. This part, yeah, I see. So this part is connected in 3 spots, actually 4 spots. First one is this transistor's output, then it's this pin of the EEPROM, and then it's this GPIO pin, and also the resistor right next to it. Uh, I'm only typing so that it is quicker, quicker. Yeah. So is it still in focus? Sure hope so. Um, yep, should be. Okay. So just to clarify, is 3.3 connected to what we would now call ATSHA, or the same shorts with the EEPROM? Uh, that's great and all, but do you have the 3.3 volt short to the MCP interrupt part or to the ATSHA part? EEPROM clock is short. So no, I mean, I cannot write faster than I speak, but there's like 10-second delay between me typing things in chat and me saying things on the stream. Aha, I see. That's really weird. I think the part, if you are saying you have a short between this pin and the 3.3 volt pin, then what you have is you have a short somewhere in here. That is, you probably removed too much of the solder mask, and you probably shorted the pin like this trace to neighbor traces. So what I suggest, so what you might want to do is you might you might even like try and maybe reheat the part, this part, maybe put some more solder with flux onto it. Okay. So somebody's pinging me on RC. Oh, okay. Okay. I was asked to open the doors to the hackerspace, which is a single button press on the xerophone. Okay. So let's see. There's something that I can suggest. If you have scraped too much solder mask off the traces, what you can do is you can lift this pad either using a razor blade or something like a knife, maybe a needle. Okay, using a knife is not the best idea. So I'm probably going to find something that doesn't melt. Okay, so what I can do, well, first of all, yeah, reheating the joint, adding some flux should clear things up a little bit. Basically, it's ideal if you have like not a solder blob here, but just this really tiny joint between the trace and the transistors pin. But failing that, you can actually remove the pin from the trace. I just need to get something like, no, a blade, I guess. Ah, I can actually use tweezers. So that's what I'm going to do. So yeah, it's possible to break the transistor this way, the transistor pin, that is. But right now the pin is lifted, it's not connected to the trace. Actually, oh no, ah fuck, I just dropped a bottle of juice. I'm quite happy it was closed. It was, yeah, okay. And now you can check, like you can try and remove all the solder from this area, like, and you should probably still try and add some flux as usual. So I don't know, something like that. Just remove as much solder as possible. Oh, you probably couldn't see that. Oh no, I forgot that I should check my camera as often as possible. So yeah, basically you just add a little bit of solder, which contains some flux. And then you clean the area a little bit, and you take all the excess solder. But this is, I can either fix it later or take 5 minutes to do it now. I understand what's most likely wrong. I think it's better if you do it now, but it's not required. It's just that you can see this outline on the board. This is the outline that the pi 0 is going to be covering, like that. So it's not going to be very convenient to fix it later. And now it's time for this beautiful roll of solder, which is explicitly named China crab. I don't know if you can see it. Yeah. So I'm going to show a little bit of just how bad solder works. Actually, let me see. Maybe this solder just only works because there's... Okay, no idea why, but I'm going to try and clean it a little bit. Maybe it's the temperature. Okay, so for some reason the China crab solder works better than I anticipated at the moment, so I cannot actually display it. But what I can say is that you definitely have to have a higher temperature set, because right now I'm soldering these solder joints with 350 degrees Celsius. So let me see if I can actually solder something useful. And what I'm going to solder is the GSM modem pins. I see. Mm. Hmm. Uh, you don't have to solder everything later, but that's mostly because I'm mostly doing this stream so that I can show you things. So it's not a stream for like anybody else to like it's only a stream I'm making because you've asked how to solder it. I'm going to make proper videos about this later, but right now take your time. I'm just going to try and solder this GSM modem. So let's see. It goes surprisingly well, but this is first of all, it's the China crab solder, but the soldering iron is at 350 degrees. So maybe that's something I haven't tried yet. Take a few minutes to fix my short. Okay, and in the meantime I'm trying to figure out what was wrong with this solder. Answering to Jerome's question, this is the 2G modem. It's SIM 800, and you might even be able to read the email code. uh, I don't think it's going to be very useful, because you don't know who I'm going to send this phone to, but still. Okay. The one day I'm not in IRC. Oh, but you are subscribed on Twitch to the notifications, right? Because you can get email notifications when streams start. And, well, yeah, pretty much it. And also, I've sent out a notification on Twitter as well. How's the Twitter, by the way? Ah, it's okay. No, it's okay. I'm going to. I don't want you to get in trouble. I do not think it's really feasible to get somebody in trouble just because you know their email code. I don't think there's a way to do that. Okay, is there something I could do? Ah, yeah. Okay, I'm going to bring a connector here. Mm -hmm. Is there some problem with the stream? Oh no, it's just lag. So the new version is as stable as it gets now. This is the version like the revision before it. So it's not great, but it's workable. And meanwhile, I'm going to solder something that FNUX, I don't know how to pronounce it, but he has it already soldered, and that's the JST connector. So in the through-hole version, you just have to solder 2 pins, and you probably will want to solder one of them, and then check whether the connector is soldered on straight. It isn't, so I'm going to reheat the pins a little bit and turn it a little bit. Yeah, should be better now. Now it's straightened out, seems. Now we can turn it around. We can solder the other pin, and after it cools down, we can reheat and add some flux to the first pin. Is this video recorded? I find it still informative. I'm going to upload it to YouTube. I actually uploaded the previous Zerophone assembly videos to YouTube, but I still have to press publish, and I have to make some kind of description for them. Also, they are not as useful as you might expect, because it's basically like full 24 hours of like altogether. I was like assembling the Delta Zerophone that time, and also making the PCB fixes, well, some of them, and basically designing the next revision. So it's not that useful. And also I'm going to want to resolder these 40 pin header, because it's kinda crooked. The soldered joints are not pretty. Oh no. What I'm going to try is I'm going to still use the shitty solder. And it flows surprisingly well. Fixed. Oh, that's awesome. So you no longer have a short, right? If you do, the worst case is that you can actually remove these transistors, and then I can send you a board that you can install with like 4 wires, like 4 solder points. And so if you cannot fix, I don't. What was that about? Sorry, because it's like 10 seconds between me saying something and you writing an answer. So if you say I don't, I no longer remember what was that about. Um, but yeah, I'm probably going to design a really small PCB that I can send out to people, where you have to basically solder 4 wires and cut a trace. Ah, okay, awesome. So right now I am going to show a little bit of modem soldering, just for practice. So the point is to have 2 pin headers here and here. I have soldered this one in the meantime, but we can solder the remaining one right now. So what I'm going to do is I'm going to place it, and also I have to place a spacer right here. You should have received one of them in the mail. I mean 2 of them. If you haven't, but actually I have figured out that these PCBs need 4 spacers. So that's a problem. Well, you can install 2 of them later. I'm going to show where they are needed. But for now, basically that's how you place the header. You place the, which one was it? Ah, yeah, this one. This one is yet unsoldered. Why do we need the spacer? I'm going to show you. Basically, let's remove this spacer and just install the modem as it's supposed to be installed. So as you can see, first of all, there's a soldering, like there's a small problem of the modem not being aligned. Like it's because of this yellow capacitor, it doesn't stick. Like there's some space between the. Hmm, how do I explain it? Basically, it's supposed to rest on the headers, but because of the yellow capacitor, there's a gap here. Uh, Here, yeah, that you might be able to see, but you probably aren't. So if you like install it, then it's going to wiggle like that. There's no guarantee uh, of the way that you are going to be able to solder it. It's basically basically probably are going to solder it diagonally. And also, the more important part is that you have to plug in the antenna here, right here. Mm, oh, right. Okay. So you have to plug the antenna here, and uh, I forget the spacers. Yeah, I actually realized the need for spacers only yesterday. So that's the main reason I haven't told you. It's probably it's going to be fine. But I'm going to like it's something that's going to be um, included in the instructions. But yeah, if you manage to like solder the if the modem is shifted in one diagonal, you're going to be able to plug the antenna. And if it's shifted in the another diagonal, you're not going to be able to. Basically like that. And even right now, it's going to be a stretch. Let me just grab an antenna and show you. So there's this beautiful antenna, and the connector is actually pretty thick, so it doesn't even actually fit here. So on my phone, what I did is I heated up these pins a little bit, and then I inserted the tweezers like that here, and while heating up I just lifted the modem a little bit, and then I also reheated these pins. What about installing the antenna beforehand? And also, I think you want to be able to change the antenna. Absolutely, that was the intent. If you actually take a look on Zerophone Gamma, that's how it was done. But I realized that I had to flip the modem for better layout. So here on Zerophone Gamma, the modem wasn't flipped, but I had to flip it because both the microphone traces and the power traces were going across the layer, and that was a very shitty thing to handle because it's more noise, more layout problems. So I had to flip the modem like 180 degrees, and I will have to unsolder the seam breakout to put the antenna. Shit. Well, yeah. So what I'm going to do is I'm going to first yeah, I'm actually going to turn my phone off, and I'm going to show you a little bit of how you can do that. It's off, so I'm going to put it aside. I'm going to disassemble my phone that's currently going through mechanical testing in my pockets and all kinds of testing actually. Oh shit, actually I still have a solder joint here which is not supposed to be here. Let me focus on that first so you can see how I fucked up. So actually I think I didn't want to disassemble the phone when I was no, I just forgot to remove the solder. So there's a solder joint here that's not supposed to be here, and okay, there's no flux either. Fuck. Oh no. Let's just flood it with solder a little bit. So what I did then is I'm going to unplug this poor antenna and try to plug the new one, the one that I'm showing, just so we can figure out just how much we need to lift the modem up. Wait, I cannot find the old antenna, the new antenna for some reason. Here it is. So let's see. Can I plug it in? Yeah, I kinda can, but it would be better with a spacer. So what I'm going to do is I'm going to put some solder. Okay, there's a lot of lint here. I'm going to take a brush. Then I'm also going to turn the lights on. There's a lot of lint from my pockets and dust, basically. Wow, it's been like, oh, look at that. Would you look at that? Add that to the list of reasons why we need a case, basically. Oh, the spacers rolled out. Oh. What I'm going to do now is I'm going to add some solder here. Actually, let me just fix it in the holder. And, right. Oh wow. To move it like that. And now I am going to try not to burn the camera. What I'm going to do is I'm going to add solder to all these pins. And now I should be able to just lift them up a little bit like that. How's that? And now I can do the same with these 5 pins, just for maybe symmetry, and see if it's parallel to the board. Yeah, it probably is. The one pin that you will want to heat up a little bit longer is here. It's the ground pin. And now there's some, yeah. So what we have now is we have a slightly more space. Let's try inserting the antenna here. And it's doable. It's very insertable. You just will probably want to plug it in with a knife, just so that it plugs in well. How do I show it? Oh, it's focused. Here's a knife. I should probably avoid bending the connector. Oh no. That seems like failure so far. Yep, like that. Basically so that you make pressure onto the antenna itself. And now we can unplug it. And we can come back to soldering on the yet unassembled xylophone. Okay, see. Okay, I'm going to power my xylophone on and let's continue. Is the stream even up? Um, mhm. Let's see. Does the... I can still see it. Okay, great. I had a problem in the browser or something along these lines. So yeah, still alive. Great. What I'm going to do is I'm going to remove the GSM modem. I'm going to add the spacers. This spacer has to be added so that it doesn't interfere with the antenna. Even though it's not going to interfere with the antenna likely, but still, yeah. So what I'm then going to do is I'm going to place the modem onto the headers, onto the spacers, and I can actually fasten it somewhat like that, even though I think it's not going to be possible for anybody who has soldered on the capacitor, because for this board I still have to get the capacitor. Okay, oops. Yep. So this one I'm going to attach it a little bit later. Right now what I propose we do first is soldering the modem headers. So I'm going to come closer a little bit and refocus. Yep. And the modem is going to wobble a little bit, but the extent to which it wobbles is not horrible. So I'm just going to solder the first pin and press it down with my fingers. Maybe reheat it a little bit, and then I'm going to see. Okay, it doesn't wobble too much, but what's important is that there's both contact between the pin and the PCB. So on FNOX picture, I actually haven't. I have spotted some places where this is not really the case. So I'm going to show, just in case, how you solder that. You have to hold a little bit your soldering iron between the PCB pad and the connector pin, and then you can probably feed the solder into the pin at any spot, and the connection should be nice and clean, and maybe press the modem down a little bit more when soldering it. And here again you will want to maybe heat up the pin a little bit, and then you can have nice and clean solder joints like that. Okay, is it shifted a little bit? I hope not. Yeah, it seems parallel to the board so far. Yep. Especially on the GSM modem, the two pins that are important are this one and this one. This one is the ground connection, and this one is the power input. And since the modem is able to consume a lot of do you know how hot the iron is? I mean, the soldering station's display shows that it's 350 degrees Celsius, and that's, I think, how the thermocouple, it's the reading of the thermocouple somewhere in here. I'm not actually sure about the temperature, but I figure it's pretty close. And also, something else that I have is this sponge that you basically put water in it and you can clean your soldering iron's tip, which is pretty cool because there is a lot of black gunk from the burnt up flux usually after you solder. So I'm still soldering with the shitty solder, and it's surprisingly good so far. These pins are basically modem's GPIOs and microphone inputs outputs. Well, basically microphone input and speaker output. So we can maybe inspect them, the joints a little bit. So this, from the look of it, this joint is not very sufficient. And let's see here. And these joints are small, but they're looking quite good. And I think this is something that's good to aim for. I'm going to hold the camera with my mouth for a little bit. Oh. Done. Unfortunately, I don't have as much hands as I would like to have. Okay, nice and clean. So it's something that you will want to basically all of your solder joints to look like, and that's because the quality of solder joints is going to be quite important for the Pi Zero. Now let's refocus, and I actually have soldered some like the 5-pin header to the Pi Zero to the Zerophone backboard already. I'm just going to go ahead and solder the 6-pin header, and after soldering the first pin I'm going to press the modem together with the board just to make sure again that it's aligned. I'm also going to check it visually, and it does seem like it's nice and aligned. Here and here. Hi. And at this point we don't have to realign the modem anymore, because basically it's soldered in 3 points. Yeah, these are sound effects. That's the new sound effect pack you can get on Twitch. Just for $3.99.
350.
Yeah. Kur? Tai vēl kādu pārstāvu. Šitais ir divpusējs LTS. Okay, so this is not too bad, especially with that kind of solder. I'm going to say it's okay. That's what I'm going to say. Especially given that I haven't removed any of the small capacitors. Even though you can actually omit them, if you accidentally remove some of those, you can just not bother. If you remove some of these, you're going to want to either replace them or just replace them with the same inductor, or you're going to want to replace them with a solder jumper. So there's that. So now we have the modem, we have the JST connector, something before we solder the Pi 0 on, we have to solder the USB port on. I'm going to see, in case, where's the pin snips? I have seen them somewhere here, cannot find them. Ah, here they are. So in case you have really like long leads here, like this kind of long, you're probably okay. You're probably going to want to wear safety glasses. The point being, if you have too long leads here that might interfere with the USB port, you'll want to snip them down after soldering. Otherwise, here's the USB port. Insert it, and yeah, solder. First, probably solder this pin down, or maybe one of these, because actually if you solder this one, for example, it's going to be easier to adjust the USB port. Now let's see if it's straight. It's kinda straight. I'm going to okay, and is it level? It kinda is. So now what I'm going to do is I'm going to solder the remaining shield pin on. Then I'm going to see there's a problem. First problem being that this headers level is going to be the level of the Raspberry Pi. So if there's a lead here, there's a possibility that you're going to it's going to scrape through the Pi's solder mask. So again, tin snips to the rescue. Like that. And like that. And now there's also that I actually want to install a mod board, but on this board I haven't thought it through very well. I'm going to show you now. For now I'm just going to remove this capacitor without any explanation, because that's how it's going to be quicker. But I'm going to show you right now, don't worry. I just have to fetch the board from wherever I store it in my backpack. Not here. Not here. Not here. Camera is out of focus, of course, sorry. I didn't actually mean to focus it, but I should have done it now that I think of it. Okay. I think I was looking for something else and then I forgot what I was looking for. Ah, right, the solder wick. So here's the beautiful, wonderful solder wick. What I'm going to do is I'm going to use it to make the pads flatter, like this. I also made the connectors a little bit non-pretty. Okay, so right now I'm going to test out the way that an expansion board is supposed to work. So bear with me. The expansion board is so fucking small that I cannot actually find it. Here it is. So it's a crypto EEPROM, like crypto authentication board. It's based on ATSHA 204, and it's supposed to be installed in a way that you cannot remove it without disassembling the zero phone completely, as in removing the Pi Zero, which takes a lot of fucking time. So here's how I invented like a small method to attach the board, because basically this board makes it possible to sign messages using the private key that's stored inside this small chip. So there's that. And I have now installed the board. What I'm going to do is I'm going to scan the I2C bus. I'm going to use my zero phone for that. I don't think I have this guy. Can you confirm? You don't, because it's a mod board. It's an add-on that I haven't even assembled at the time I was sending out the PCBs to you. So let's just try it out. Yeah, it's a small little guy. It's a really cute small board. So there's ground, there's power, and let's say it's going to be I square C. By the way, there's instructions here, the pinout, and I actually have to put my zerophone back together, so that's what I'm going to do first, before connecting all the wires and stuff. Sorry for the small interruption. I'm going to plug in the antenna once again. The antenna problem is only for the 2G board. On 3G add-on board, the antenna is on the right side, even though this 3G board is not actually suitable, but still, it's okay. Okay, so I've almost assembled my my own zerophone, and plugging it together. And I also have to kickstart it, basically. I have to connect the charger to my phone so that the protection board is triggered and the battery is connected to the phone. So I have to plug it in the charger into it for a short, small while. And now it's booting. So we're going to see the UI appear somewhere there. And in the meantime, I'm going to continue connecting cables. So that would be data, and this would be clock. Nice. And since I cannot remove the board after soldering the Pi 0 on, but I cannot easily test it before I solder the Pi 0 on, unless I use my adapter, which I cannot be arsed to do now. I'm just going to plug the zerophone into another zerophone and hope it doesn't burn up. It's not going to, but it's just a figure of speech. So white and white, and there's gray, and what I'm going to do is I'm going to no, not this one, this one. Okay, and we have this x64 address I2C device, which is exactly what is supposed to happen. Now we're going to remove, and we're going to rescan, and it's not there anymore. So the add-on board works okay inside the Pi 0, inside the zerophone, and I'm just going to finish by soldering the USB connectors data pins and trying to avoid soldering to the expansion board. So yeah, this is the first crypto authentication mode that I am installing into the Zero phone. I hope I'm going to have to remember that it's in this Zero phone, and I'm probably going to send it to some kind of person who is going to be interested in tinkering with this mod. And there's also a capacitor, which on delta B it's supposed to be it's placed here, but I had to remove it in this revision because I didn't think about the board placement. So there's also a small capacitor here, but it's more for the chip itself. I have no idea whether it's best for me to place this capacitor or not. I think I probably will not do that because I can do it later from the other side. Okay, I cannot do it later. I can actually add it here if I want, if it fails me. I don't think it's going to. The capacitor's only here so that you can uh, so that there's no problems when you insert power-hungry expansion boards, and even then it's not really necessary. Um, okay, so we have the USB connector connected. The step up we can add later. What's the chip number for the crypto mod board? Let's see, ATSHA 204A. Here's that. And now I hope that FNUX, or I should learn how to pronounce it. I hope you're still with us because we're going to attach the Pi Zero finally. I just had to show some soldering because it's a bent pin, because it's sort of a requirement when you're soldering this Pi Zero to this header in the way that I have devised. So let's see. Yeah, still here. Okay, nice. Let me see. I am going to solder the USB wire, this one, and then I'm going to have a couple of like 2 or 3 minute break, just so I can eat some food, maybe answer some questions while I'm at it. Just that I'm not going to solder while I'm eating. I think that's generally a bad idea. But first, of course, I'm going to get some wire. That's something that you have to get. For the USB wire soldering, I am going to have, I think, 2 centimeter, something like that. Then I'm going to take pliers, and I'm going to take the tin snips. Maybe a knife would also work pretty well. So what I have to do is I have to remove the insulation from the full length of wire. I'm probably going to go with the knife. I usually go with my teeth, but I cannot show it on the stream. How long do you plan until the end of the stream? No longer than an hour. So yeah, I'm probably going to use my teeth. I hope nobody noticed. Um, now there's half of insulation here. What I'm going to do is I'm going to thin it a little bit. Basically cover it with some solder. Just so that it holds together while I remove the second part of the insulation. Important question, FNUX, is it okay for you? Can you last for 1 more hour, or should I do it quicker? Let me know. Okay, so this should be kinda okay. I just have to thin the whole wire. So that's what I'm going to do. You probably will not want it to hold it in your hand while thinning it. Otherwise, it goes something like this. Now you have to bend it in half. You have to cut it. You have to bend it a little bit more. And then you have to cut it so that the ends are of equal length. Like that, let's say. Then we take the pi 0. Well, let me see. Let me see. Um, so I am going to highlight. Alright, I'm going to highlight the thing for FNUX real quick. Where's my trusty paint? Here's it. So there's a screenshot with the red circle going to matrix any second now. Has it went through IRC? No, not yet. It has. Okay, so to FNUX, if the red circled part is solder, you might want to clean that up. Otherwise, I'm going to put some solder on the test points, and I'm going to take our loop of wire that we made. Let me see if the stream is up to date. Probably going to position it like that. I'm going to take our loop of wire. I'm going to solder the first end, and I think that's something where I could probably use some decent solder. Also clean my tip. Um, okay. Yeah, something like that. Maybe remove a little bit of solder from here. Oh no! This was not part of the plan. Yeah, basically, if you have something under the pi 0, be prepared that you're not going to be able to rework it easily. Everything else should be fine under the pi 0. That's the only problem part. Okay, so I'm going to try again. Like that. Then like that. Okay, I need to add some... Ah, that's the shitty solder. I need to add some decent solder. Okay, I think it starts to fail a little bit. Okay. So as you can see, we won't have to finish the assembly for today. It's going to be tomorrow. Okay. What we have here is we have a loop of wire that connects the test points together. We're not going to leave it forever at connecting the test points. Okay, should be more visible. And now what we have to do is we have to put the pi 0 on the header and pull this loop of wire through this hole. Focus. Let's do it. I'm going to put a piece of wire through the hole and then put the pi 0 on the header, like that. Then I'm going to bend the wire. Then I'm going to cut it. Like that. And the last thing, I am going to solder these wires to the test points, while taking care to not heat up the wires too much, so that they don't desolder themselves from the pi 0. Okay, the soldering is not pretty, but it's going to work. Right, we have the USB port soldered, so that's nice. And now we have to check whether the pi 0 is nice and flush and parallel to the board. That's something we have to have. Also have to have a minimal offset between pi 0 and headers here. So now the offset, like ideally the offset shouldn't be noticeable. I'm going to show you the idea of it. Basically how Zerophone works is you have the front board, you have the back board, and these both plug together like that. So here you have to have as the least amount of solder possible, and fortunately there's some groove, like not grooves, but basically some inset spacing here, even though this header doesn't actually have a lot of that. Okay, that's unfortunate, but still, I'm going to show you the idea. The idea is that you heat up the pad, you heat up the connector, and then you make sure you add the least amount of solder possible. Okay, fuck, that wasn't really visible. I'm going to readjust the camera. And I probably should have another angle, not of my jeans, but of the...
Я просто эту программу для CNC сделал. Хочу попробовать посверлить деревяшку.
Я не понимаю ничего в CNC.
Нет, просто я предупреждаю. На всякий. Да, как бы уже вроде разобрался.
Окей, если что, ну, пробуй, и если что...
Мне сразу по этому. Я строгий сын, не лучше.
Ничего. Если что?
Да, если что.
Если что, скажешь мне, я подойду. Sorry, small interruption. I'm going to try is I'm going to put my camera right like that. Refocus it. Like that. Okay. And the point is we're going to want to put the front board on top like that. And of course the solder blob is quite big. What do? We use the solder wick. So now there is a bare minimum of solder, but there is still connection between the pin and the pi 0. We can plug the front board on top of that, and it's going to be almost flush. I mean, flush for all intents and purposes. So this is the idea. Now I'm going to make a sandwich, and if you want to add some, like ask some kind of questions, ask away. And then I'm going to solder this pi 0 real quick. And I'm also going to time just how long it's going to take for me to solder it. Because first of all, this part is the longest one. It's basically the most error-prone part in the kit assembly process that I know of for now. So that's a problem. That's a problem, alright. Then there's the question: can we automate it? And if we can, how? I'm going to bring. Are there plans for reinforcement structures? It looks a bit weak to carry in pockets even with a 3D printed case. I'm going to answer. Can you hear me, by the way? You should be able to. Um, let's see. So it's actually quite strong, unexpectedly so. There are weak spots I'm going to show you right now. So the first one being the speaker. So I think I have to add some kind of super glue to the base, or maybe hot glue, because this speaker keeps detaching itself, but still we need a case for that. We need a case for the LCD panel's edges, because they tend to break off, and if they break off too far, the LCD breaks, as in, well, there's lost lines, and then we need to have a case because of these weak spots in these buttons need the reinforcement in form of some kind of case around them, because they tend to disassemble themselves if they get stuck on some kind of thread in your pocket. But otherwise the Zero phone is quite okay. Also, in last revision there was a Velcro um, glued here, but now it doesn't attach because there's all kinds of chips in this space right now. What I'm going to do is I'm going to probably either replace these chips with something, or like, I don't know, an Atmega maybe, or I am going to maybe just add a 3D printed spacer of some kind that could also attach the battery to the backboard. So there are weak spots, sure, but in general the phone is quite okay with being carried in the pocket. In fact, like this phone, I was carrying it in my pocket uh, for the last year, like during the first half of this year, and even though it has all kinds of stuff happen to it, it's quite decently working still. I had to like desolder the connector for my needs and so on, but if I just remove the jumper, I should be able to power it right up, and basically stuff like that. It, it's okay, it's decent, and it works well enough. And even though the reason why I set the standard for the front and backboards to be 1.6 millimeter PCBs is that the 0.8 millimeter PCBs, um, they have they have bent, most of them that I've seen. They work, it's just that they're bent a little bit. How is the battery life? Has it decreased or increased from revision to revision? It let me think. I think it has increased, mainly because I have implemented some battery charging improvements and a little bit of power saving, a little bit, and it's not fully implemented yet. But I think the last revision is as good as it gets in terms of power consumption. So there's that. Hmm. Hmm. how much can I expect? 10 hours as told? If I have told somewhere that it's going to work for 10 hours on a single charge, that's wrong. Send me a link so that I can fix it. The figure I am consistently getting now is 20 hours. Oh, 10 days installed? No, not that much, unfortunately, because the Pi Zero consumes plenty of power. So the figure right now is like 20 hours on a single charge with this huge battery. And the plan is to get it to like 25, I think 30 hours, and then move to a flatter battery. Mm. Hmm. Mm. I read somewhere 10 days, let me look it up. Yeah, because I don't think I would ever say such a thing. I've built Pi Zero variables before this phone, and the consumption is one of the problems. Okay. How I use my Zero phone. I think you're speaking of uptime, which is basically I wake up. My typical uptime. Okay, I'm going to make a correction there. Because doesn't seem obvious from here. Yeah. Uh, so I can see how that could be misinterpreted. The thing is that there is a workflow that I'm working that I use with the Zero phone, that you come home in the evening. When you go to sleep, you plug the charger in, and when you wake up in like 8 hours or so, you disconnect the charger, and then you go on your merry way, and you do stuff, you make calls and so on, and there's like 20-day period, wait, 20-hour period which it lasts, and in this period you just have to connect the charger back. And you can also, I am going to have dock stations, so if you have like a workplace, you're going to be able to buy a cheap dock station board with probably some laser cut case, assemble the dock station, and when you come to work, just plug the phone into the dock station so that it can charge. Okay, let's finish the stream. Let's solder the Pi Zero, and then the backboard is going to be ready. So first I have soldered the 2 pins. Let me switch. Yeah. I'm going to refocus a little bit. I have soldered the 2 of the pins, and they look decent enough. I'm going to solder the pins in the front first, and then I'm going to switch the side and solder the pins on the back. Okay. First I have to see if there's... Oh, I'm going to adjust it better. so I can press the pi 0 a little bit into the... Okay, should be fixed now. So now what I do is I heat up each pin and I feed, and also the PCB circle. Then I just feed the solder into there. Afterwards I'm going to clean each of these solder joints up, then remove the excess solder. By the way, is the sound too loud for you? Let me know if it is, because I'm right next to the camera. So once again, it's the solder is cyano. I cannot show it. So let me try. Cyano. It's leaded, and it's a huge spool that I have already used up some, and that's these solder joints is not something that you can get with each, like with random soldering iron and random solder. But if you pick the right solder, just this is not even the expensive solder, and this is not even an expensive soldering iron. Sorry for the shaky camera. Okay, we have made all the solder joints in front. We're going to remove the dirty solder wick. And now let's just remove all the excess solder from the joints, and we can even do it like that if we want. It's tricky, but you can absolutely do it. But then you're going to um, go through the individual pins. You're going to take a look at them and see if maybe one of them isn't pretty. Maybe the last ones were done in a rush. Okay, there's one which seems as if it had more than others. Let's inspect. So there are some which look shorted. This one, yeah, but they aren't. There's just the flux. Otherwise, we have nice and flat solder joints. Let's plug in the front board, and it comes nice and flush, except for some pins in here, it seems, which are kind of visible, but it's also acceptable. So I'm just going to unplug the board carefully without bending the pins, Can I also ask software related questions? Sure, go ahead. Should they to the issues IRC? As a rule of thumb, if you think other people could contribute or benefit from your comment at large, um, then it should probably be on issues or on IRC. But if also if we can sum up the discussion afterwards in issues, it also is going to work. And I see I have fucked up this poor connector by accident. Maybe I should solder it afterwards. Yeah, I think so. Um, that feeling when it fits perfectly. Yeah, absolutely. It took me some time before I understood I could just use solder wick. Before that, I was just soldering the pins very carefully. Okay, the camera cable doesn't belong here. Then now I'm going to rotate the board. So yeah, feel free to ask your software questions. And meanwhile, I'm going to solder this first pin. Doesn't solder very well because it's a ground pin. I have to hold it a little bit longer. Okay, I should probably figure out. I will put it in issues afterwards. Do you plan to write like a desktop? Like seeing clock, battery status and connection strength? Sorry, it took longer to type, no problem. No problem with taking your time. Are we going to write a desktop? Do you mean like desktop? I don't think you meant what I mean by desktop. I think you meant like lock screen type of thing. If so, there's already one that I just have to fit in the ZPUI code somehow. But I already wrote an experimental main like type of screen that you're describing. I just am waiting for the moment when I'll be able to plug it into some kind of like ZPI trigger, or I don't know, because we have a lock screen application at the moment. I don't have it committed to Git. I just have it in my local tree. The problem with it being we do not yet have some kind of facility for lock screen to trigger, so we should probably have that. I'm going to check your link as soon as I finish soldering it. You also will want to be careful here and here, because there are surface mount components nearby. Now we have these pins soldered, and the next thing is going to be solder wick, and then we're going to be done. open in new tab. It's not multitasking, I'm just doing a mechanical task and reading at the same time. It's not really multitasking. Yeah, I see what you mean. We like there's a lot to unpack here. There's there's first of all, there's a notification on the screen as well, as in full screen notification with some kind of action like press a button to read. Um, I don't yet have an idea of how we are going to implement notifications, but um, we are going to have the main screen, and we are going to have like the battery indicators, the screen status indicators, all kinds of stuff. And I also want to make this main screen in a way that also will allow for third-party plugins, like, you know, a weather plugin or something like that. Okay, you have to be careful here as well, because there's the SD card slot and you can cover it with solder accidentally a little bit. There's one pin that doesn't have enough solder. Let's see if we can maybe reheat it a little bit. Okay, better. Now let's remove the solder. There are the teeny tiny I2C pull-up resistors here. Those two black ones. You also will not want to remove these ones. Fifth pin is the ground pin, so it's going to take a little bit more temperature than others. Okay, how's this one? Good enough, I think. Okay, snip off. Now these ones, again, have to be careful. I think we want a proper way to discuss between software, ZP software components first. What's that issue? I don't remember what was the first issue in the repo. Yeah, you see that framework is actually not that important overall, because we are probably not going to be using that framework I'm describing to write apps. The framework is mostly for scenarios like for example, suppose you want to make an app that launches MJPEG streamer, which is an application you can use to stream from stream to the internet, stream like make a local stream from a USB connected camera. So here you go. You can you want to launch the MJPEG streamer process, but if your app crashes, you don't want to make the process crash as well. And this framework is something that I devised for the apps to use in case you want to, like, for example, you want to launch FFmpeg decoding process of some kind, and it's going to run for a long time. And actually, the more I think about this GitHub issue, the more I think that first of all it's really I think I should at least, I know, not at least, but maybe rewrite it just to explain the scope further. And also we need to open the proper issue of how do we actually implement communication between applications and ZPUI, because at some point ZPUI is going to be split into the base framework with some base applications and the applications themselves. So you should be able to load applications from like I know, from like a random Python package. I know how to explain it. Basically, you should be able to. It's more about for notifications or triggering a lock screen would largely benefit for something like that. See, the trigger mechanism can be implemented quite well using the constructs that already exist in ZPI code base. By and large, I just have to figure out the proper way to frame it. Uh, because we have a local RPC. Okay, I probably should wear glasses. But I'm just going to hide behind the camera instead. Ah, okay, almost worked. Did I get some in my coffee? No, in my tea. Okay, let's refocus the camera and inspect the solder joints. Okay, so you might notice that um, there's a single bad solder, like not full solder joint. Let me see where the tweezers. Here they are. Oh no, somebody is murdering the CNC in the next room. So here's the bad solder joint. You can see that even though there is contact, there's also some area where there's lack of contact. But if that's the worst solder joint you encounter, it's pretty cool. If that's the worst solder joint you have on your board, you have done a pretty good job. Overall, I see there are some joints. Like for example, I have actually would like to clean up these 3 pins, but otherwise it's pretty well. It's pretty well soldered, but it does require solder wick. It does require a little bit of, I don't know, training? No, probably not. Okay. How does the underlying OS handle this, and couldn't we just hook on that for the notification? I have to ask, what exactly are you asking about? Is it the lock screen or is it something else? And in the meantime, I'm going to plug in the backboard, and the front board, I mean. And let's see. Okay, so it's pretty good. It's plugged in mostly well. But as you can see, it's shifted a little bit. like it by diagonally. That's not the intention, so I'm going to pry it apart carefully, because you cannot pry it apart here. You have to pry it apart a little bit here and a little bit here if you want, if you don't want to bend your pins. A little bit here and a little bit here, like that. What did I want to do? Yeah, what I have to add is we have to add the spacer here, like that, and we have to also add the spacer here. So that's originally what the spacers are for. So we add these spacers. Now the phone is more parallel, even a little bit too parallel, I guess. We have the pi 0. That's awesome. Let's plug it in and see where the smoke comes out. I don't know if I actually have a suitable SD card. For now, I think we are just going to check the 3.3 volt generation. Oh no, the spacer fell out. I should probably glue them to the board, to the header, I mean. Where's the spacer? Oh no, got lost. And found it. Let's see where the smoke comes out. Yeah, you know, I'm that's, for example, one of the main reasons that you will want to check, for example, the resistance between let me turn the resistance mode on, and you have to check the resistance between pin 1 and pin 2 in both ways, so that really short beep is because of the capacitor charging. So let's clear one moment up. Most of the zerophone logic, as currently is, it's in ZPUI. There is no X server, even though there is a frame buffer driver. The zerophone uses the display directly, and the Python, like the ZPUI, handles everything, basically display output, keypad input, backlight control. There is indeed Raspbian, but it doesn't really know about display. It doesn't really know a lot of things about zerophone internals. We're going to change that. There's going to be an API, but there's not going to be a backlight API. The backlight is still going to be controlled by the display. And there is also no lock screen as such if we don't implement it in ZPUI. So there's that. Okay, I am probably going to take it like that. I'm going to switch the multimeter into voltage measurement mode. I am going to connect the ground probe to the USB port metal, because that's where we have the most accessible ground point for a crocodile clip, like that, so we can measure voltages easily. And the first voltage we will want to measure is 3.3 volts. Mm. So where's my power adapter? Here is it. Oh, I'm sorry for the shaky camera. Here's the official Raspberry Pi power adapter. And let's plug it in really quickly. Does anything heat up? No. Let's unplug it still. And now what we're going to test for is we're going to test for 3.3 volts. Then I'm going to answer on software questions. Where is 3.3 volts? On the 3.3 volt pin, and that also means that there's 3.3 volts on another pin, C, and there is. What about battery voltage? It's cool, right? It even powers the modem a little bit, even though it's not supposed to. So yeah, I'm going to go ahead and say that the soldering was successful. I am also going to plug in some SD card. Since we have proper voltage, it's not going to have to be a sacrificial SD card, even though I can actually plug in my sacrificial SD card, because why not? So that's an SD card that you cannot actually reflash. It has a Raspberry Pi image, and every time you try to rewrite it, it goes through, but then when you plug it out and back in, there's still the same Raspberry Pi image. So that's weird. Okay, we have the green light flashes. So that's cool. Look out for the smoke. Which is not there at the moment. It's probably going to come at some point. I mean, it's likely not going to. Okay, by the way, how much do we have on the charger? 5 volts, 520. That's cool. That's very cool. And we have the SD card blinks and so on and so on. Pretty cool, I'm going to say. So we have assembled everything we wanted to have assembled at the moment. Spacer. Okay, put the spacer on this pin, this header, then put them together. And it's assembled. I mean, mostly because there's also going to be keypad and the screen, and the speaker amplifier, and the speaker, and something else probably, vibromotor, stuff like that. Here we also have to have a DC-DC. Nevertheless, it's an assembled phone. It's a phone. Okay, it's an almost assembled phone that I just dropped. Okay, still you can drop it. I mean, it's going to survive for the most part, unless you have the display mounted, in which case Maybe don't drop it on the floor too much. It's still going to survive, but the screen can break. But then you can buy a $6 screen and replace it. So there's that. Oh no, that wasn't supposed to happen. I'm sorry for that. Just moved it to a safe place. Ooh. So let me see. Pry part here. I see some SMDs here. On there, is this label obsolete? Which label? No, I get it. Yeah, no, it's not obsolete. As in, I'm going to probably have to have a guide on prying it apart, but basically, this is the section where you have to pry it apart, and it goes something like this. You just have to have strong fingers. I mean, relatively strong. Mine aren't. But yeah, you will just not want to pry it apart like this. It's a bad idea because you're going to bend the pins here. So yeah, by the way, I think it's a tradition of mine to drop a camera at least once per stream. It's always happened. Okay, but we could use dbus and implement something like org free desktop notification in ZPUI. We could. I have actually looked into it. There is some kind of daemon that we could rewrite. There's the because why I looked into it is that I want to at some point where when there's going to be like some kind of zero phone light desktop, I would like to have notifications coming in like into all of the sources, like both into ZPI and also to the desktop. And I also want to be able to receive like notifications from apps into the ZPI, so I think it would make sense for us to reuse the existing notification standard. The problem is that it's going to be quite an effort. Okay, not quite, but it's going to be an effort nevertheless. There are some applications, like there are a couple of like custom notification handlers using the free desktop notification standard. I think one is written in Python and we could reuse some parts from it. Uh, it's still going to be an undertaking, but we can do it, and I think at some point we should do it. So there's that. Um, but still, we should also uh, think of more like which kind of notifications applications are going to send. How are we going to send them to the user? How are we going to show them to the user? What's the most efficient way? Uh, Python 2 or Python 3? Okay, I'll answer that. So what's the most efficient way from usability perspective? And what's the most efficient way from the code to, like, for application developers to easily integrate application notifications into their applications, even though maybe there should be some kind of entry like level of like there should be some complexity to sending notifications, because otherwise people might use notifications too much, but then they are probably going to use it anyway, so we should probably also have some kind of tool for ZPI users to filter notifications they will not want to see. Couldn't we copy the older feature phones on that? Not really. Not really, because the amount of notifications and the type of notifications they have is quite limited. So we can copy them to some extent, but we also have external applications which older feature phones didn't really have. And even if they had, there wasn't often any kind of SDK to use the notifications. Šī tēma vajadzētu būt. Cik laika?
Gribas šito handshake skatīties.
Lol. Kad?
Nezinu, kaut kad.
Šodien?
Nu, gan jau, ka nav.
Okay. Okay, so if I haven't answered your question, let me know. These are my thoughts on notifications. This is something that I haven't yet even started implementing. I have just spent some time looking into it and looking for like Python code we could reuse, and thinking about usage scenarios. Why use it Python 2, not Python 3? Inertia. I have like the predecessor to ZPUI is PyLCI, which was written like, I think I started writing it like 4 years ago. I think I published it officially like 2 years ago. And oh my god, something's breaking over there. And okay, that's distracting. So I used Python 2 because it was installed by default on Raspberry Pi. It was basically installed by default everywhere. And all this time I mostly spent adding features and fixing bugs, and not trying to implement Python 3 compatibility. So there's that. I think it's kind of an oversight, but I think that we have at least 1 year to move to Python 3, or so it seems, I mean. And it's in Python issues, like it's in ZPUI issues too, so so there's that. That's a good start, I think. Yeah, that's pretty much it. Okay, FNAX, I hope the tutorial was good enough. If not, if there's something missing, if there are some questions, feel free ping me on IRC, and I am going to respond as fast as I notice. Do I have a link to this issue? I should have it on the first page. Where's that? I think okay. Is it all in my head, or do I really not have it? That's weird. There's the packaging ZPI for Debian, Raspbian, and then code selection. You know, that's pretty fucking weird. Should have mention. Okay, that's weird. Um, I know, I know. I actually have this issue open on PyLCI GitHub, where it isn't that popular. Like PyLCI isn't as popular as anything, like Zerophone, so I have mistaken it. Um, Feel free to open it for me if I don't have the time to open it myself in the meantime. I don't see it in discussion GitHub either. I'm sorry that that was a mistake on my part. Uh, Thank you for the stream. Thank you for participating. Um, yeah, sorry, my mistake. Um, mhm, yeah, I fucked up here. We'll have to open it. Um, okay, what the fuck? Um, the ah, I think, yeah, I also mistaken that one for another issue because it's still about PEP compliance. It's um, yeah, here's that. Is there Python 3 support? Okay. One more thing I have mistaken. Um, so yeah, this is an unrelated, like not so closely related one. Uh, Whatever. But I have to add it to my list of things I should open issues about. Like there's GitHub issues, and there's also a list of issues I should open, like list of topics I should cover. Mm, I just have to find where is it. Um, uh, Not seeing it. Ah, yeah. Oh, I actually have Python 3 port in the list of topics I should open issues about thing. Um, in this one. Okay, whatever. Um, Thank you all for participating, and I'm going to be available on IRC. Last thing, Jerome, Waffly, I'm going to check it out. Jerome, you might want to join us on Matrix. Um, Developer first, project management. Ah, nice. That's okay. Track your GitHub issues and pull requests with an automated workflow. Hmm, I'll have to think about it. Okay, so Jerome, you will want to probably check out Matrix if you want to be in the chat more permanently. Take the red pill. Mm, it's quite cool. um, Matrix. Ah, no, it's in the discussion. Uh, if you how the fuck does this work? I don't know exactly what you're speaking about. The thing is, Matrix is like new generation um, chat software. If you look in the list of nicknames in our channel, that's what most of the people are using. You can see the M after the nickname, so they are using they are in the Zerophone chat through Matrix, and the nice thing about that is that you're there permanently. You don't have to like join, leave, you get the history, you get the direct messages. Like anytime you join the chat room, you can see the history of that chat room. And it also bridges to IRC like Freenode, and the bridging is pretty much seamless. So you're not going to experience like any bridge related issues. Uh, I have linked the GitHub issue. You can also help us a little bit by adding a tutorial as you go along the way. Basically making screenshots, and uh, then you can publish them on our wiki so that people like can join easier. But basically you make an account on uh, Riot IM, I think, and you just need your login and password, maybe email, I don't remember. And then you have an account, you can join the chat at any time. There's also like smartphone applications, there's a web client, and one of our contributors that you have seen in IRC, David Magai, I believe, he's working on Matrix applications for Zerophone, and it's coming along very well. This is from what I'm seeing from the code, so we're probably going to have we're going to have Matrix on Zerophone soon as well. I suggest you check it out. Uh, that's probably going to be it for today. Yay! You have joined it 10 seconds ago. Nice! Um, just make sure that you have joined the right room. Yeah. Thanks for streaming, thanks for watching, and see you next time.